an application of invisible XML, which Stephen will speak about later on today, in fact after my talk. This is called transparent invisible XML. And the motivation for this work was a project called the link extractor, which we built 10 years ago, we started. And this program recognizes references in legal text, so you can think of laws, treaties, court rulings, judgments, etc. There's a lot of legal material out there. And there are references in there that only consist of text. So it could be a court ruling referring to article number such and so of this or that law. And we want to enrich those documents with links so that you can actually click on the reference and then you go to that part of the other document. And this link extractor has been in use since 2015. It uses named entity recognition for all the names of laws, treaties, etc. It uses parsing expression grammars to analyze the structure of the text. And it was written in Java 8, Apache Cocoon, and XSLT2, which means by now it's technically obsolete. And several of the customers using this have said, yeah, we can't use this, it's not safe anymore or secure. And we try to show, yeah, you can still use it, there's no risk, but they wanted to upgrade it anyway, and we said, yeah, well, that would be an interesting project. So at the moment, we've started to re-implement this using Java 11 or higher, xQuery 3, XSLT3, and invisible XML. So what does the link extractor do? Here I've got a small part of Dutch text. The other text will be in English. And in number 3, I don't know why it's 231, I'm not a legal expert, but there's a link to this article number 2.14, member 1 of the BVIE. That's some kind of treaty about intellectual property. And the link extractor analyzes this part, it recognizes the link, it provides a link, and on the website of this court ruling, you will see that there's a link and it says click here if you want to see related links for this article. And then when you click it, you go to a page which tells you everything that we know about this specific article of that law, including the outgoing and the incoming links. So we have now created a whole web of links between legal documents. So that's what we don't want to do again. And we want to use invisible XML. There will be in XPath and XML 4 this function, fn invisible XML. It takes a grammar, which is a text specification in XML. It takes some options about how to parse. Those go into this function and it generates another function. That's the box over here. And that takes a string, just a piece of text, which it will parse. And then the output is hopefully a structured XML document indicating how the input text was parsed. It could also be a parsing error. That's why it says it's an item. It's not just an XML element with all the parsed content, it could be an error message. So how can we use XML to recognize these references? Here I have part of a report for the Council of Europe. This is from the website. It looks like a piece of text, although the slanted A here already gives something away of what's about to come. So we wish to recognize this link to Article 40 of the Statute of the Council of Europe. And this is an XML grammar rule. We now still have parsing expression grammar rules, but this is an important part of that grammar. It says that a reference is a part type, like article in this case, followed by some spaces, followed by a part ID, which is 40.a. It specifies which article we want to refer to. Some spaces, then an off thing, in this case that's off the, but it could be any number of phrases, some spaces, and then in this case a treaty. It could also be a law or something else. In this case it's a treaty, the Statute of the Council of Europe. And the first part is optional from here to here. So a reference could just be a treaty if you want to refer to the whole treaty. Now here I have the part of the XML of the underlying document. So we have a paragraph, there's this text, I've marked it yellow, what we're going to recognize. Here's the grammar again, and when you feed it this part of text, when you feed that into the parser, it will create an XML tree, which I've shown here. It's a reference with a par type article 40A of the Statute of the Council of Europe. So this seems fairly easy, but now the problems start. Problem number one is that Invisible XML parses the whole input text. And that's not what we want. We only want to mark the interesting phrases or pieces of text, and everything surrounding that, which I've double dashed here, is not interesting for us. We only want to match the recognized parts and provide some extra markup so we can make links of those. So the question is, how can we ignore but also keep the surrounding text and just mark up the bits that we've recognized? Now, there are several solutions that we could provide. So one thing would be to use this funny pattern to ignore the surrounding text. This means it's not one or more occurrences of anything, which means anything goes. However, this is ambiguous, because in XML there's no way to indicate the shortest such match. So this a good parse would be to just parse the whole document with this pattern, throw away all the references, and that would be very valid. So we would not recognize any of the references in the text. Also, if you would add this, and it's actually a bit more complicated than this, it obfuscates what the grammar is intended for. So ideally we would just like to specify the parts that are interesting, that are the references, and ignore anything outside of that. So a better solution would be to tell the parser to match only fragments from the text that have actually matched, and to do so repeatedly, because there can be multiple references in the same document. So in order to do that, I added some parser options. By the way, I did this for the markup blitz parser made by Gunther Rademacher, which he integrated into BaseX. And on Thursday, I also presented my own integration into ExistDB. So you can use iXML now in both BaseX and ExistDB. And for my implementation in BaseX, I added the options multiple matches, which says you can match pieces of text and do so repeatedly. Skip unmatched words, which means all words. We can go into definition of words, but let that now. Just skip them when they're not matched. And we want to have the longest matching text fragments. So when we do that, we run into problem number 2, because if you may have seen already that within this piece of text that should be recognized, there are XML elements. There's an emphasis element around the A. And that's a problem, because the parser that's generated by Invisible XML has a string as its input. However, this is structured XML. Actually, it's not really structured XML. It's some text nodes, then there's an emphasis node and some more text nodes, and we want to match halfway the text node. So how are we going to do that? So one solution, which we actually did in the previous phase of the project, is to serialize the whole thing to text. So we get a serialized version of the XML document, and then to have a small XML parser in our grammar. Actually, sometimes it takes up most of the grammar if you want to do it correctly. And again, this obfuscates what the grammar is intended for. It was not about parsing XML. We have perfectly capable tools for that. We only wanted to match the references. So it works, but then you have to serialize, run the link matcher, recognizer, and then to parse again. So it's also quite slow if you want to do this and you do the parsing in multiple phases. So another solution would be to throw away the XML elements and just keep the text. After all, then we just have a string of text, and we can parse that. If we use these matching options, we can get the right fragments out. But then we need to put the elements back because we don't want to have a mutilated document. We want to enrich the document. So we need to find a way to put the elements back. And the way I've done that is to make the XML structure, which is marked red over there, transparent. So the parser parses the XML document or part of it, but it doesn't see the XML elements. So that's why this is called transparent invisible XML. And in fact, if I have this rule that I showed before, then the transparent invisible XML parser will ignore these XML elements, and it will parse the text and then put in these bold XML elements, which result from the parsing using IXML. Then it will put the emphasis back, and we have an enriched document with additional XML elements. So now it's time for the demo, which is always a bit of a, I think it worked, yeah, good. So this is the BaseX client. Just to show that it works, I'll run this and go back over here. So here I have the input. It's the same piece of text with the emphasis. Here I've got the grammar. This is my reference rule. This is a part type. In this case, it's only article. The actual grammar is a lot more complicated than this. There's a part ID, which is a number optionally followed by a dot and A to Z. No emphasis there. And then we have off, which can be a comma or an off with an optional space and the. These are spaces, and the treaty for the moment is just the Statute of the Council of Europe. So if I run this, this is the output, and you can see indeed we have recognized a reference, part type, part ID, the treaty, Statute of the Council of Europe, and here ends our reference. So we have successfully recognized this. Now, of course, we want to recognize more treaties, so here I've put in a lot more treaties of the Council of Europe. There are like 267, no, a bit less, but so I can run that as well. And now you'll see that we also have recognized as a treaty the General Agreement on Privileges and Immunities of the Council of Europe, which is the second treaty of the Council of Europe. However, we don't know which treaties these are. And I think that's what I'm doing here. So the same input text, same grammar. However, treaty can now be any of these. Oh, it's 224, actually it's a bit more treaties. So I've got a rule for all these treaties. And then a treaty can be any one of those. It should be, that's up here, yeah. So this works, but you can imagine if you want to have all the regulations that we should recognize, it becomes very long. And I'm not going to run this because it will actually crash BaseX. So what can we do about that? Well, we can, instead of using IXML for recognition of fixed text strings, I'm using named entity recognition. So I've also made a named entity recognition function in BaseX. The code is online. There's a link in the paper in the proceedings. And then I have a different kind of grammar, which says the CETS 224 is this text. And you can specify multiple strings separated by tabs, etc. That's explained in the paper in the proceedings. So I've shortened it a bit here. I've left out a couple of treaties. And then these are the options for named entity recognition. I'm not going to go into that. It's sort of explained in the paper and on the GitHub repository. And then I have this named entity recognition function, and that will give me a treaty, and it has an ID of ETS001, like specified here, and ETS002. And this is much faster. Actually, the previous slide where I had this long list, it will crash base X, because when I put in 267,000 titles of laws and treaties, well, it doesn't work because I tried it with 10,000 and I need 8 gigabytes of heap space, which means to put all these names in there would require more than 200 gigabytes of RAM. And I haven't found a good laptop with that amount of RAM. So let's go back quickly to the presentation. So yeah, I skipped this because I'm running out of time, but this is basically what I said. So this is the function for named entity recognition. It's very similar to the invisible XML function. So you have a grammar, which looks a bit different. You have options, and it yields a function from a node, because we are now parsing XML documents, and it gives a node, which is the XML structure that comes out. We've had this. So now we run into the third problem. I've recognized these treaties marked in yellow over here, which is great, because I have this grammar rule specifying that we want to find a treaty. But I just made all XML elements transparent. So the XML parser will totally miss these treaty elements, which I did on purpose, because I don't want it to see these XML elements that may be in the document. So yeah, we've shot ourselves in the foot, so to say. How can we solve that? Well, an easy solution, which I've implemented at the moment, is to surround the treaty elements, or the content of the treaty elements, by special markers. They should be a bit more complex than 3 square brackets, but that's what I used for the example. And then a treaty, so here I have a treaty, and it's specified by this rule. It can be, it is the beginning marker, some text, and the end marker. And as you see, this must be the shortest match, which we can't guarantee at all. But it works sometimes. Maybe it will work now. And then this will be our pipeline. We have an input. We do named entity recognition. Then we have a step to mark the treaties. That's just an XLT. We give that to the XML parser, and then we unmark the treaties. So we remove those red markers again. That works. But actually, what's even better is to use what I call pre-parsed non-terminals, which means that we make only some XML elements in the input transparent, but other XML elements can be accepted as part of the XML grammar. And that requires a modification of XML, which I show here. So here I have, I thought let's use pointy brackets, because we use those anyway in XML. And if you use this notation, the parser will parse everything as usual, but it will see that at some point in the input there's a treaty element. And it will pretend that this treaty element from the beginning to the end of the element is a non-terminal. So it's like it's pre-parsed. We already did that in a previous step. And now it says, okay, this is pre-parsed, it's non-terminal, and it skips the whole content of the treaty, including text and possible XML elements, and then it will continue parsing after that. Here's a picture showing that. Here's a reference. We have this pre-parsed non-terminal at the end, the treaty. Par type matches with article. Then we have 40 with some transparent element A, then we have an of the, and this treaty element, actually I told the grammar to recognize that as a treaty, non-terminal, and everything inside it gets parsed. This is still work in progress to add this to the XML parser. I'm working on it because we need it for our project. I think I can have it ready in August or September, depending on what other things I have to do. And I think the important part of this is that transparent XML can now be used to either ignore or accept XML elements, which means we can use invisible XML to enrich XML documents, not just plain text. And there's a lot of XML documents out there, well, I wouldn't say much more than just plain text, but we really like those documents, and until now, invisible XML could not really enrich those, but with this edition, it can. So last demo. Did I do that? No. Here I have the demo with the markers. So it's a lot of code, but here I have a marked treaties. Here you can see the special markers that I put around it. Here's the unmarker style sheet. Then we have the XML grammar. And here's the pipeline I showed earlier. And then when I run this, indeed, I get a reference of this treaty. It's just like nothing has happened to the treaty. It's still there, but now it's part of the reference. It has been recognized. But this is with the markers. This is not yet with the pre-parsed non-terminals. Sorry. So, having said that, I'm right on time. Thank you. Thanks to Gunther Rademacher, who really helped me out with a lot of questions I had about his markup blitz parser. Thanks to Stephen and all the other people involved in Invisible XML. Thanks to the XMLPrague organizers and you, the audience. The code is on GitHub and links are in the proceedings, so I'm not going to show them here. Thank you.
Thank you very much, Nico. It was been really interesting. So there is a question from Stephen and Norm, but Norm has been quicker, so Norm first, you second.
Excuse me. Thank you, Nico. That was really very interesting. There's half a dozen ideas in there I want to explore, and nobody wants to listen to us chat for the rest of the day. So one quick question. The obvious concern that occurs to me is if you take the markup out, the transparent markup out, and your grammar adds more markup, and you put the transparent markup back, how do you address the possibility of introducing overlap?
So that is in the paper in conference proceedings. I use a technique that I introduced several years ago called a separated markup API for XML, or SMAX, which separates the text content of the document from the markup. It remembers the character positions. You can even change those when you insert or delete something. Then after whatever you want to do on the text content of the document, it puts the XML structure back. But that's explained more fully in the paper and on the website of SMAX. So I have several strategies to balance the tree again, etc.
Okay, so next question from Stephen.
Well, it was more a remark. You said it has to be the shortest match at one point.
Yes.
But if you make that a not closed square bracket, then you get the shortest match.
Thank you. Okay, I'm going to change that immediately.
So it's time for additional coding. Third question over there from Tom.
Am I doing this? Sorry. This is this thing.
Yeah, so we will do it. So we just use it.
Okay. Yeah.
Another question?
Thanks. I got very excited because this is what I do with a more traditional, classical, regular expression machine. And so I'm interested, is this reasonably faster than the regular expression approach using iXML?
Yeah, when we started this in 2013, someone had already made a program using regular expressions to recognize legal references. He compiled those regular expressions from parts, and the regular expression went up to 5 or 6 pages. It became very slow, and also there was a bug in it that no one could fix. And I'm aware of several initiatives like the Building on ECLI initiative in the European Union, and they all try to use regular expressions, then they found out it doesn't work, so we need some kind of subroutine thingy in regular expressions, and that's a lot of work to program that, but you can use parsing expression grammars for that. Basically, parsing expression grammars are an extension to regular expressions.
One last question.
Hi, thanks. I was just wondering whether you had considered using invisible XML pragmas as a way to extend the markup in your grammar rather than the angle brackets so that it remains compliant with the specification?
I haven't considered that, no.
Cool.
I need to think about that. Thank you.
Thank you.
Okay, so I don't see more questions, so thank you very much again.